Okay, so this recording is to answer some of your questions. So we did 2 economics examples today, and some people in the response sheets said that they would like a little more on that. So for one, I'm going to try to record an explanation for those 2 questions, so hopefully you can slow it down and figure out where the concern is, and then you could give me a more focused question. Okay, so we had an example. It says find Q to maximize pi, which is profit, and it has to be Q is less than or equal to 1,000 items. R of Q was given to be 5Q minus 0.003 Q squared dollars, and C of Q was given to be 300 plus 1.1 Q. So you have 2 options. You can either calculate P, then find P prime, set it equal to 0, solve for Q, and then verify that this a max. Okay, so that's what we're going to do. We're going to follow these steps. So pi is equal to, that's profit, revenue minus cost, and so it's 5Q minus 0.003 Q squared. And now if I'm going to put parentheses around C so I can subtract it from R, I have to remember this sign has to switch. Okay, so I'm going to just minus 300 minus 1.1 Q. Alright, I could combine these 2 terms, but I'll kind of do that at the next step. Okay, pi prime is, alright, so what's 1 minus 1.5 minus 1.1 is 3.9, so 3.9 Q, take the derivative and you get 3.9. And this piece just disappears because that's the kind of constant that drops out. And then we have this piece that we need to take the derivative of. I don't think many of you have trouble with taking the derivative, so I'm not going to go into detail about that. Alright, when we set this equal to 0, we solve for Q. Okay, divide both sides by 0.006. Alright, and you solve for Q, and so what ends up happening is you just end up getting 650 units equals Q. And there's more than one way of showing all work or justifying that that's actually the correct maximum. You could simply say this is a concave down parabola, therefore it has exactly 1 max, and here it is. Or another possibility you can just say Q is equal to 0, 650, or 1,000 must be the max, right? Because we found the vertex of this parabola, but if this is the vertex, it's a max. But if instead we have this kind of parabola, it would be a min, and in that case, either at Q equals 0 or Q equals 1,000 would have to be the max. Okay, so we don't really know which situation we have. Alright, so let's get rid of that. Okay, so if we don't really know, we can just say profit of 0. Well, that's stupid. You sell 0 objects, you get 0 profit. Actually, it's negative. So negative, really. And then you calculate pi of 650, and you get 96750, and that's the actual answer. The pi of 0 is actually minus 300 if you feel like calculating it. It's not necessary. And then see, pi of 1,000, it turns out being 600, not max, and this guy is definitely the max then. Okay, so let's go to the next question. This one is maximize revenue. I'm not going to write the whole question out, but we have at a price of $80 for a half-day trip. See, that's there to try to distract you. It's just a trip. A whitewater rafting company attracts 300 customers, so you get 300 is equal to items sold, right? Items sold is tickets. Every $5 decrease in price, so for example, let's say you go down to $75, results in 30 more customers. So we sell 330 items. Okay, and we want to find demand function. And the implied instruction is find the demand line curve, because 2 points determine a line. So it's the most basic model we can use. We're not going to use exponential decay or growth for this. So we go ahead and do our thing. I'm going to just label x1, x2, y1, y2. Items is Q. And I'm going to make price P. Okay, but I'm going to use y equals mx plus b because most of us find it easier. Change in y is 30, change in x is 5, but look, we made a mistake. In a demand curve, always price and quantity are counterposed, so the slope is always negative. So even if you make this little mistake, you can say, oops, I'm supposed to have a negative there. All right. Now what I'm going to do is I'm just going to take any old point. I'll just take the first point, why not? And I'm going to put all that information into this function. Okay, so I have 300 equals minus 6x plus b, and then 300 is minus 480 plus b, so 780 is b. And so what I have is the demand line is y is equal minus 6x plus 780, and so that means y is q 780. So this is the demand curve. Okay, and the next thing is find the revenue as a function of price. Revenue as a function of price. R as a function of P is what? So what we do is we take this bit here. Okay. Edit. Paste this guy in here, and this piece I want to just cut and put down below. That's cutting that. There we go. Alright. So we start with this guy, our demand curve, and revenue is P times Q. Revenue of P or revenue of Q. It doesn't matter, P or Q, it's just the same thing. Revenue is price times quantity. So revenue is equal to price times quantity. Excuse me. Okay, and then the next thing says, so I didn't give you all the parts of the question, but the parts of the question are always the same, or very similar each time. Part C says, find the price to maximize revenue. Alright, so we have to take the derivative, set it equal to 0, and solve for P. So we get 780 is equal to 12p, or 780 over 12 is p. And then you just type that into your calculator, and 780 over 12 is equal to $65. It maximizes revenue. And again, we need to justify this. This is a concave down. How do we know it's concave down? Parabola, right? It's just that negative sign. Right? We just know it's a concave down parabola because the leading term starts with a minus sign. So has a max only, no min. So when you find it, we're already done. We don't have to check the endpoints. And let me draw a dollar sign. And maybe it should be a green dollar sign. There we go. And there we maximized. So hopefully this will help some of you. And I will be happy to go over it in my office or whatever. Okay, so hopefully that's helpful.